Ladies and gentlemen, good job. Okay. Finish some oatmeal. Okay, take a look at. Ooh, interesting. I'm going to go through again, like I do every day, to remind people that your lectures are recorded. Where are they recorded at? And placed. I put them in Canvas in the module section titled Lectures with the date. And so today's 9/27/2023. We're going to talk about today, though, is another rule. These are formulas. Okay, and I'm going to go to 261 on my website. Worksheets and videos. This is going to be derivatives and the what? Quotient rule. So do you guys know, what does quotient mean? Do you guys know? If you say a quotient rule, what in the world is that? Let's go through here. Yeah, so let's go through the iPad, and we got quotient rule today. Good, nice, fun. So, by the way, just to kind of generally talk about this, A over B, okay, this is division, by the way. Division is AKA the what? The quotient what? Rule. What does quotient mean? 2D what? Divide. I'm just going to this is quotient. Quotient means to divide. So it's almost like saying, Mr. Judge, we have a division rule. Well, really, you have two functions now. Or still. F of x over g of x, this is still division. You say, what do you mean? This is still to divide. It is still a quotient. But now it's just two functions. We call this, by the way, rational functions. So this is AKA, a lot of times they'll say, oh, R of x is f of x over g of x. This is a rational function or a fraction function. So we're going to try to find the derivative of rational functions. And to do that, you're going to say this is d dx of, let's give you a quotient now to divide. This is not a product. This is a what? Quotient. How do you guys know it's a quotient? You should see a division sign. Okay? Quotient rule. Okay, f of x divided by g of x. This is quotient rule. Now, there is a proof in the book. And I'm going to say to you guys, I'm going to have you guys read the proof before I just spend the time to prove it to you guys. It's on page 150. No. It's on page 151 of your book. Okay? And that's in the book. There's a proof. So let's differentiate a quotient here. Let's give you what's called quotient rule. That's equal to this, okay? It's another quotient. You're going to take the denominator function, and what you're going to do is you're going to what? Square it. Yes. Okay, so here's your g. You get to square g. Now, g of x times what? d dx of f of x minus f of x d dx of what? g of x. What you're seeing is something known as the what? Quotient rule. And make sure, ladies and gentlemen, you have here, this is going to be subtraction. Okay, this is quotient rule. Now, I remember the day, here's kind of a shorthand for quotient rule. You know, if you just write it this way. G squared. G times f prime minus f times g prime. Okay, and again, you might say, what about Mr. Escalante? I remember the day I came in and seeing quotient rule he had on the board. He liked to use shapes like triangle over square. And I remember he was actually a math teacher in Bolivia before he came to the U.S. So, you know, he was using this for quite some time. So I remember the day that was quotient rule, and I'm like, what in the world is that? And, you know, even if you just say, well, what does Mr. Judge do? He uses those colors even, because I think sometimes colors are what? Are helpful. You know, so you take G and you square it, you bring that G back up, and then you differentiate your what? F. And then minus that F times, and you differentiate the G. Don't forget these derivatives. So there it is, ladies and gentlemen. This is the one and only quotient what? Rule. So like I told you guys. And, you know, so there's going to be some algebra. But again, we got to go through some of these, and I'm going to look on my website at some examples. All right, and again, I have to apologize. I guess I'm going to call it W like I started yesterday. So W is going to be x over x minus 4. Okay? The top function is f, and the bottom function is what? G. F over G. Okay, so they're going to say now, determine what? W prime. So, ladies and gentlemen, here is the operator notation that we shared with you guys there, okay? All right, so your numerator is orange, the denominator is green. So what do you do with the denominator? Automatically you what? You square it, ladies and gentlemen. Okay, isn't that what G, I don't know which one you want to use. You got 3 versions. G, square that. Let's put in the denominator. And then bring g right up here. This is how I see it. So you bring that g back right up here. Go, okay, here's that g in green. So now, in my mind, I differentiate the other function, which is x. I differentiate the other function, which is your numerator, and then I subtract. That's something that people may forget. Subtract. And then you say, subtract what? Do everything now, I should say opposite. Put the f there and differentiate g. Derivative of x is 1. The derivative of x minus 4 is also 1. Is that true? All right. So, ladies and gentlemen, okay. So, we're on our way, right? So, this is going to equal now, what is this? X minus 4 times 1 minus x times 1, everything over what? X minus 4 squared. Anything times 1 is itself. What do you guys get rid of? Your x's. What do you have left? W prime x is going to be what? Negative 4 over, what's this? X minus 4 squared. There you go. There it is. Mm-mm. There's no simplification. Mm-mm. You're done. Easy peasy lemon squeezy. Okay. Anyway. All right. Wx is 5x over x plus 8. This is all going to be a quotient rule question. Okay? So we're going to find the derivative now. Okay? You guys okay with this? So far, so good? So what do you guys do with this now? What's the derivative of 5x? And the derivative of x plus 1? Is that 1? Okay. Okay, so what do you guys do with this now? You're going to have to do some what? A little bit of algebra. 5x plus 40 minus 5x. Everything over x plus 8 squared. So, ladies and gentlemen, what happens now? Don't you cancel? And then you're left with what? 40 over what? X plus 8 squared. Easy peasy lemon what? Squeezy. Yeah, I don't know. I guess today we're going to have to use another box to draw our conclusion, right? All right. What do you guys think? Is that okay? Quotient rule? That's not too bad. We just have to keep kicking these things up, right? You say, what do you mean kick it up? Well, x plus 2, x minus 5, another quotient rule question. So everything that we're going to do today is quotient rule. How can you guys even identify its quotient rule? What should you see? Division. They should call it division rule. But the word quotient is another word for division. So numerator what? Denominator. What do you do with the denominator? X minus 5 squared. X minus 5. Differentiate x plus 2. Subtract. Bring out the x plus 2. And you differentiate what? X minus 5. Okay, so I'm just going to color. This is kind of like I said, the denominator squared. Bring up the denominator. Differentiate the numerator. And then do the reverse, but make sure you always put the what. This is subtraction. Product rule is addition. So, that's kind of one thing I think it's very important to remember. That's where some students will make a mistake. And again, use operator notation because that's going to be very helpful to tell you what to do. Like, what's the derivative of x plus 2? 1. Good. What's the derivative of x minus 1? Or 5? 1. Okay, so now the rest is going to be what I say. You're kind of cleaning this up with algebra. So you have this x minus 5 times 1 minus x plus 2 times 1. Everything over x minus 5 squared. X minus 5 minus x minus 2 over x minus 5 squared, and your x's go away. Negative 5 minus 2 will give you what? Negative 7 over x minus 5 squared. Now, I want to kind of remind people that, if you have a negative number, like up here, okay, you know what you guys can do? If you're looking back at the book, you're going to see this. They put the negative sign there. Because a negative divided by a positive, it's kind of like in algebra. You got a negative 2 over 3. You write it as the negative sign at the same level as division, right? That's all. So there you go. Not that big a deal, right? Okay, what do you guys think? Is that okay? Okay, now remember, don't get upset. Like you say, what if but they always like to give me f of x. And maybe if they gave you f of x and they have 7x over x squared plus 5, they're going to have you find f prime of x. Okay, so if you are familiar with the quotient rule, because you have a quotient, And there you go. Okay, is that quotient rule? Right. So what's the derivative of 7x? Do you guys remember? 7. What's the derivative of x squared plus 5? Is that 2x? Is that true? Okay, so remember, put all of the see what we get. We get what? 7x squared plus what? 35 minus 14x squared. Everything over what? So what do you end up with? I'm going to do it this way. 35 minus what? 7x squared over x squared plus 5 squared. And this is f prime x. So you might say something like this to me. What I've noticed personally, you might want to put that negative 7x squared first plus 35. But I've noticed in calculus books, or even math in general, as you start to take higher order math courses, I don't know if it's superstition, but they don't like to start terms with negative values. So that's why you'll see 35 minus 7x squared, and that's okay. Doesn't have to be in descending order for your polynomial in the numerator. So you're fine if you're looking back at the book and you see this, you're fine with that. What do you guys think? Is that okay?
So both answers are acceptable?
Yeah.
Okay.
Because in terms of arithmetic, right? I mean, subtraction, yeah. The reason both are acceptable is if you have a minus b, that's the same as negative b plus a. They're equivalent statements. So that's all I'm saying. You can see the numerator as negative 7x squared plus 35. And if you do, then that's fine. Or you put it 35 minus 7x squared. So just kind of let you guys know that that kind of shows up. Okay, so remember, I transitioned to f, but because a lot of times we generally like to describe f for functions. And it's still the same format, meaning you have a numerator over a what? Denominator. And then that might be why I wish I can ask Mr. Escalante, right? Because I think that's why he put triangles and squares, so people don't get confused and say, hey, isn't this numerator supposed to be f? What's going on with f? Because some people will get confused with that, right? So I think that's kind of why he might have done that. It's interesting, but okay. All right, so we kick it up. Should we have you guys try some?
Yeah.
Just for fun? You say, Mr. Judge, you can't take all the fun away. All right, we'll give you a couple of them.
Yeah.
5x plus 3 over 2x squared plus what? 1. Okay, we'll give you guys some time to try these, and then let's give you another one. What's going on? Okay. Did you guys have fun yet? Let's see what these answers are, okay? Answers. Let's go with these. Okay, I guess I can leapfrog here. Let's try it this way. Okay, ladies and gentlemen, here we go. Let's be consistent with blue. Blue. There we go. No, I mean this goes. All right. What do you do with the denominator? Square it, and then what do? You bring it back up here. What's the derivative of, ooh, we can't see. What's the derivative of 2x squared? Do you guys know? 4x, okay. Okay, so you have now what? You get this what? 3x plus 1 times 5 minus 5x plus 3 times 4x. Everything over what? Okay. Okay, so let's do the distributive property. Let's do some multiplication here. And see what you get. You get what? 10x squared plus 5 minus what? Isn't that 20x squared minus 12x? Okay, and that's over at 2x squared plus 1 what squared? Is that true? Okay, so now what do you get here? What's 10x squared minus 20x? Is that minus 10x squared? And then that'll be minus what? Well, 12x. Oh, yeah, minus 12x. I apologize. I should drink that coffee. Plus 5. Everything over? Yep, there you go. Easy peasy, lemon, what? Squeezy. There you guys go. Is that what you guys got? Pretty good. Not too bad, ladies and gentlemen. It ain't too bad. Okay, and then now let's do the one with the radicals. You're going to say, that's the first time I've seen this. Yeah. Let's try these out. It's an x minus 3 squared. I'm going to have to bring it down, I think. I always do because I'll run out of space. Okay, now bring up the denominator again, right? Okay, you guys okay with this? Does that look like it's okay so far? Yeah. Okay, now notice this. We haven't even taken a derivative yet. We just put it in the format. Is that right? So I'd highly recommend you get started as soon as you can writing down this format in operator notation like we're doing. Okay, I highly recommend it because now all you got to do is remember what? What are these derivatives? You guys remember this? What about yesterday I said, did you memorize that square root function? Yeah, 1 over what? 2 square root of x. It shows up a lot. It's a little something. And then this derivative is just what? 1. So now we get x minus 3 times that 1 over 2 square root of x minus just the square root of x. And then everything's going to be over what? x minus 3 squared. Okay. And now what might happen is people say, well, what do I do with this, right? Well, the simplification with algebra, take your whole number and multiply it with your fraction. So you're really getting the following. X minus 3 over 2 square root of x minus square root of x over x minus 3 squared. Okay, so far so good. Now, you're going to subtract, right? We're going to subtract rationals. I want you guys pay attention to that denominator. This is the algebra. You're going to need to subtract two fractions. So multiply the top here by 2 squared of x divided by the bottom 2 squared of x. So you get now x minus 3 minus 2x, right? And that's over 2 squared of x. We'll do every detail. Over x minus 3 squared. So, okay. Now you have the same denominator. So divide both by the 2 squared of x. Now you get x minus 3 what? Squared. So what happens here? What's x minus 2x? Negative x minus 3 over 2 squared of x. Notice what I'm going to do here. I'm going to say divided by x minus 3 what? Squared. Because what you actually have here is known as a complex fraction. Okay, so you have a complex fraction. And the algebra is like saying I have a over b divided by c, which is a over b divided by c, or a over b times 1 over c. And that's essentially what I'm doing here. Okay, so you get negative x minus 3 over 2 squared of x times 1 over what? X minus 3 squared. Now, that's going to be multiplying two fractions. So be careful right in here. You might say, why? Why be careful right here? What you want to do here now is you think you might be able to simplify. If you factor out the negative 1, what do you guys end up with? Right? You can factor out the negative 1. In other words, f prime x becomes negative x plus 3 over 2 squared of x, x minus 3 squared. So that derivative is a negative x plus 3 over 2 squared of x, x minus 3 squared. So nothing cancels, is my point. Right? Nothing will cancel. So that's your answer. You're done.
Professor,
Yeah.
I got a different answer.
Did I do something wrong?
I got negative 1 over square root of x, square root, and times square root of square root of x plus 2.
I'm just trying to see here. Did I do anything wrong here with the arithmetic? You guys see any errors maybe? Anybody? You got the same thing? Anybody?
I use my online calculator and it says.
That's why AI is not really real. You guys know AI. I always caught a lot of people cheating when they through the pandemic. They're using this software. Let me see what your software shows you. Yeah, that's kind of a
Just
whole
to like
thing.
confirm.
Sure. Where is it at? Where's the final answer?
Yeah.
That's the final answer.
Yeah.
That's odd. I don't see any way how they can really get that answer.
You
So
got
let's see.
three beings
Let's see if they
steps.
did. Is it the same function?
Yeah.
Try it again. Square root of x over x minus 3. I think this looks like a different question.
It's the same question though.
No. This is a different question. We're differentiating this function.
Which one?
Square root of x over x minus 3.
Wait, what?
Yeah. It's a different question.
Okay.
I think he's doing the next one. You're doing the next one. Yeah, I think you're doing this one here.
Oh, okay. Sorry.
That's all right.
Sorry.
I still don't trust AI, by the way. I mean, I'm on these committees and they're talking to AI this, AI that, and I'm like, oh yeah, AI, jeez. It's like, really? My opinion is you could never replace a human being, really. Human beings need other human beings, whether you guys like it or whether I like it or not. Sometimes I just don't like that idea, but we've been learning from each other this way for thousands of years. And all of a sudden we think that's going to change overnight. I don't think so. That's my personal feeling. Although, they're trying to develop robots. Tesla has a robot. And supposedly it's going to do everything for you that you want it to do. It's like you're going to ask it to do your homework. You say, robot, do these derivatives. Okay. I don't know what you do with that then. I don't know. It's weird. Differentiate. What's the numerator? Square root of x plus 4, right? Minus square root of x plus 4 times the derivative of the square root of x plus 2. Okay. You guys know what that derivative is? 1 over 2 square root of x. You know what this one is? Same thing. Is that true? Right? You guys okay with that? Okay. Square root of x plus 2 times 1 over 2 square root of x minus square root of x plus 4 times 1 over 2 square root of x. Everything over square root of x plus 2 squared. Okay, you guys okay with this? Now, what's so nice about this? This seems to be a nicer question. Do you guys know why this is nicer? Because you already have the same denominator. So multiply that whole number . Now distribute here. Now don't forget, this is going to be divided by the square root of x plus 2 squared because you have a complex fraction. And that's going to be, you're going to cancel this. So it looks like we get negative 2 over 2 square root of x now times 1 over x plus 2 squared. Okay, so this cancels, so we get negative. Oh. All right. Is that what the AI gave us?
Yeah.
Okay. If a robot can hit a baseball, and it could hit it really well consistently, would you guys pay to watch the robots play baseball? I don't know. Robot baseball? You don't have to sign Shohei Ohtani for $1 billion. You just buy the robot baseball player for $100 million. Would you watch a robot play that baseball game? I don't know if I would. I think it took away from the game. I don't know. It's an interesting. Was that in your book? It's not in your book, but yeah, not yet. Yeah, I don't really believe all that. I do believe this. I do believe industry will try to do a lot of damage. Personally, I do. What I would mean by industry, the robot biz, folks, they'll try to do a lot of damage. The AI folks, you can control a lot of people's opinions that way, because a lot of people really aren't educated, in all honesty. They don't bother to think critically. They don't bother to read even. They believe everything they see. There's a lot of people like that. So there's people smart enough to figure out if we can control how people think, we can enrich ourselves with anything we want. We could tell people, give us your money, and they'll give them. The people will do it. That's where social media comes in. Look, Elon Musk didn't spend all that billions of dollars on Twitter for fun.
It's profiting off of everybody's negative
Mm-hmm.
emotions.
Yeah. Let's try this one. That's kind of amazing to me to think of it that way. If I can profit off of your sadness, I'm going to make you even sadder. Let's find a way to make you sadder. So, because the sadder you are, the more I profit. Yeah, I'm on all this. That reminds me, I got to tell them when I can meet. With this committee, this AI committee. Is AI writing your papers? You guys know? Yeah, you can't say. Can't say AI is writing papers.
Just chatting with this guy named GPT.
Yeah, you're chatting with who? This guy named GPT?
He's my English tutor.
It's kind
Yeah.
of true though.
I think Harvard, if I heard, Harvard has these supplemental instructor kind of things that are bots. I heard that in a meeting the other day. Anyway, did you guys get the answer for this one?
Yeah.
Shoot. Do we have time?
We have like 5 minutes.
Oh, do we have 5 minutes?
Yeah.
Maybe we have time.
No, we don't.
I wonder if that Chat GPT could beat me. Should we race?
Let's try.
I think it probably already has the answer. I could probably beat me by writing it down. Huh? Right. The problem is that you got to write everything down. I could do it maybe faster without it, but I might even make a mistake. 5. What's this? 4x. So I could be faster if I skip steps. Is this what you guys got? Did you get this answer? I don't know. Did I beat the AI?
No, you're still with just.
Still working? Huh. Sorry, AI. And I could have done it faster if I didn't write everything down the way. Good. I raced AI. Man, look at that. I'm proud of that one. I beat AI today. I'll tell the committee your AI is yeah. So we'll just wait till version 5 comes out. Like, oh shoot. Version 10. How about this idea? Could you imagine if machines learn more efficiently than people? Because they're claiming this is machine learning. I'm not so sure it's machine learning. I just think it's data manipulation. It's not machine learning. You're not learning anything. But okay, if you go with machine learning, and it does it fast, and you could put this in a chip. If you can implant this chip in people's brains, or somewhere else, who knows, in their foot, but it's, Bluetooth to the brain somehow. You don't have to ever go to school anymore. You don't have to learn. We just upload the chip. We could sit in a sauna somewhere, and we can learn just by the chip uploading to your brain. What? Criminal?
It's called Criminal on Tubi. Tubi.
TUBI. What does it have to do with criminals?
No, but so the movie, they open the brain of the dead man and transfer it to like this felon. So the felon, they insert things in his brain and they transfer the thoughts and data of the dead man's brain into this alive felon. So it's pretty much like what you're talking about.
Hmm. Yeah, imagine that. Instead of getting knowledge, you got a virus in your brain? And that virus makes people do all kinds of crazy things instead of learning? Because somebody said, I'm going to hack this person's brain?
Yeah, that's exactly what happened.
Oh, really? I didn't know that.
Yeah, that's exactly what hacked his brain because he knew.
Wow.
But you can see TUBI is really good.
Oh, wow. It never ends.
It's exactly what you're talking about.
It never ends now, does it? So if you did upload to people's brains, now you got to worry about hacking and viruses. Maybe. Maybe, ladies and gentlemen. I'm going to want you guys to try Quotient Rule on that same website that I was looking at. It's right here. And try that out. Get these started here, ladies and gentlemen. And I'll see you guys tomorrow. We'll do some trig integrals, I think. Okay, take care. Stay safe. Don't let them hack your brain.